We're in a more dangerous place now than we were 20 years ago. We can now, from halfway around the planet, take society back 100 years through software. If we ever come to a point where we're actually engaged in full-out cyber war, the future is going to be an arms race.
Any technology that gives you a route to the cache will be exploited. The biggest threat is basically anything with a chip in it, and we find it all around us. You know, credit cards going contactless, passports talking to machines at the airport. So when the robots rule the world, I only ever have to fool the robots.
I think that we will find ourselves increasingly dependent on telerobotic systems. Suppose you have a remote surgery system. If a third party were to take over that system or interrupt it, it becomes a weapon, or it could be a disaster.
I'm in Manhattan to meet a team of white hat hackers who focus on embedded systems, the unseen components that control devices around us, from tiny gadgets to large-scale tech infrastructure. Red Balloon Security is headed up by Ong Sui. They recently developed an exploit which allows them to effectively bug embedded devices without physically touching them, exposing sensitive data and leaving them vulnerable to malicious actors. They've worked with everything from printers to monitors to drones, all kinds of machines that we rely on every day, and they're going to show us just how insecure they can be.
Hello.
Hi, how are you?
Good, how you doing? Come on in.
Yeah, good, thank you.
This is where we do all of our shenanigans. There's my desk. That's the data center. This is where we do all of our hardware takedowns. When we look at a new physical device, it's very important for us to understand how that machine is made, what's really inside, what the software is, what the hardware is. And a lot of times, we just take it apart. We take apart dozens of these things. There is a big old bin of phones that didn't make it.
These are all ones that you've teared down to try stuff out on them.
Yeah, poor little fillers.
It's like a phone graveyard.
Ong wanted to show us some hacks they'd done using a piece of malware he affectionately calls Fontenna, which exploits radio frequencies, RF signals, to turn office equipment into bugging devices.
So Fontenna is basically using software and all of the common pieces of hardware that you find in basically every embedded device to force that hardware to transmit an RF signal to exfiltrate data. Right?
So that's a radio frequency?
Over RF, yes. Right? So if we had software that pushed electrons through this wire in a predictable way, then Maxwell's equations say we can induce a magnetic and electric field, and then we're going to get an RF signal that we can receive with all sorts of standard radio receivers, basically using only software. So what we did is basically reconfigure the software-controlled input pin to go to output, so we can actually convince the phone that it's really off the hook when it's not off the hook.
So you basically placed a bug into a meeting room or wherever the phone is?
Sure, through software. Right, so nobody had to sneak into this room, nobody had to tamper with the phone. It was all just software through the network. And in this case, it was software delivered to this phone through a printer. And we get the exploit to the printer through a resume. So we send you a resume. The resume rewrites the firmware on the printer to do whatever we want. And what we want to do is find all the phones. So that once we find the phones, the printer goes out and exploits all the vulnerable phones, and now we have eyes and ears in every room.
Right, let's see what it can do.
Okay, so, well, it's been doing it all this time, right? So we're gonna look over there, right? Our entire conversation was, exfiltrated to my laptop, and I guess I can turn the volume on and we can hear what it sounds like. Okay, so we're gonna talk, right? And there's a slight delay, maybe a little bit of an echo, right? But the audio quality is actually pretty good. And on later versions of this attack, we were able to do live speech to text. So instead of sending out all of his audio data, we just had the phone tweet everything that was being said.
So you're tweeting out everyone's secrets?
Yep, pretty much.
Ong then showed us how the Fontenna software could make a printer spill secrets by leaking information through RF signals. He could pick these up using an antenna. In this case, a cheap AM radio he named after a famous actor.
I'm gonna show you a really cheap AM radio, right? This guy's called Tom Cruise. and we're gonna see what Tom Cruise will say about Fontenna.
Let's do it.
All right, we're gonna turn on and see if we can.
The exploit caused the printer's components to vibrate and transmit the data as if it was Morse code. With a powerful enough antenna, a hacker could intercept the signals from a distance without ever going near the printer.
To an AM radio, that's what it sounds like, a tiny little beacon.
So that's the sound of the data that you're extricating.
Yep, exactly. There you go.
How can you turn that into something usable?
So we'll show you. And this is where this computer does this thing. So what you're looking at here is the RF version of Fontenna, right? We have the software-defined radio, we have the antenna, we have the printer transmitting over here, right? And what's going on is the antenna is piping into this tiny little box, which is being processed on the laptop, and you're seeing the same beep, 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 beep you're hearing on the AM radio. And what our software is doing is basically taking these tiny little dots, right? Turning it into binary and then decoding it over here. So the sky above the port was the color of
Television. So it's the first sentence of Neuromancer.
yes, the first sentence of Neuromancer. Right? So basically we can send out whatever data we want from pretty much all sorts of embedded devices that you have all over the place. And ta-da!
So we're hearing the Fontenna code.
This obviously doesn't have a speaker, it doesn't have a microphone, right? We're making this acoustic emanation by effectively causing the passive components to vibrate and the solenoid to do whatever it's doing.
Sounds like an old school arcade game.
Yeah, kinda, right?
So say someone was printing off some sensitive documents. If there was Fontenna loaded on that printer, then you could grab that sensitive information using an antenna and translate it back into something that you can understand.
Yeah, and even more, if somebody was saying something sensitive on the phone can send that information to the printer and the printer can Fontenna it out, right? Or you grab some information on the printer, you can send it to the phone and the phone can Fontenna it out, right? It's, there's nothing special about this printer that's allowing me to do the Fontenna transmission, right? Every embedded device effectively has the same hardware that in theory, can allow me to transmit information out in this way.
So we're not just talking kind of office secrets. This could be military secrets.
Right.
Power station.
Whatever reason you want to build a steel enforced concrete bunker, right? Yeah.
Ang's Fontenna hack is clearly pretty advanced. And what makes it particularly impressive is how it can transmit data using radio frequencies. This means it could send stolen information through walls without a hacker ever having to enter the building.
It's quite scary to think about all the systems that could fall into the wrong hands. You think about securing your laptop, your phone. You don't necessarily think about all the other devices that hackers could use to break into a network. You perhaps wouldn't expect to find a hacker in the picturesque British county of Dorset. But we're here to visit the home of Adam Laurie, or as he's known in hacker circles, Major Malfunction. Adam's a security researcher who specializes in electronic communications and is also a senior figure in the well-known hacking community DEF CON. He's going to show us some of his more recent work, and he's also asked me to bring my passport along, which I'm a little concerned about. But he promises me that he only does white hat work.
I'm in the darkest depths, back here.
So this is where you do your hacking?
Yeah, most of it.
So how long have you been doing this for?
Early 80s, late 70s.
The technology must have changed quite a bit.
Technology has changed a lot. Your classic hacker, kid sitting in his mum's basement, he can get the tools that enables him to do really highly technical attacks for a couple of $100 now. So, RFID is one of my specialities. So I kind of collect old credit cards and hotel room keys and blanks that I can use to try and clone them as I figure out how they work.
Tell us why you've got 3 what look like handguns.
For some reason, shooting and hacking seems to go a lot together. I'm into the ballistics, crafting my own ammunition, doing long-range shots. It really clears your mind. You have to be so focused.
You go by the name Major Malfunction.
Yeah.
What's the story behind that?
A lot of people assume it's from the film Full Metal Jacket. Actually, it was a dry comment that was on the background sound when the shuttle blew up on takeoff.
Obviously a major malfunction.
Kind of sounds like a baddie from the Powerpuff Girls.
Adam specialises in hacking RFID chips, like the ones found in contactless credit cards. Using a cheap card reader and some software he wrote himself, he showed us how he could easily rip information from his alter ego's card. It's a card he actually uses, so we've had to blur out personal details.
So what we've now got is the contents of the chip. So as you can see, that number should match what's printed on the card.
Yep, they look the same.
So if I wanted to now make a copy of that mag stripe, I could. I could equally have just had all of this running in a backpack, string down my sleeve, reader in my hand, going up to people on an escalator or standing behind you at the bus stop or whatever. The whole ecosystem of chip and pin is broken by design anyway. You don't necessarily have to have ever put the pin in order to do a transaction. So we can intercept the message from the terminal saying, please tell me your PIN. So the credit card never actually knows that it's been asked for a PIN, and the transaction proceeds and everyone's happy.
This is my personal passport. I'm trusting you. You're
Trust
promising.
me, I'm a hacker.
So this is the chip.
This is the chip that's sitting in your passport. Just thought you might like to see that. So if we put this guy on here, don't look at my keyboard for this bit. I'm just about to type in my password. Now all I need is the chip. Here's one I prepared earlier. This is my horrible homemade passport chip. So if I run that program again, that is now an identical clone of your passport.
So if you went through border control with this passport, it would think that I'd gotten through.
Well, certainly the machine component would be fooled. There's no difference now between that chip and that chip.
But a human might notice there's something a little bit fishy about this.
If a human ever gets to see it. But that's the point. When the robots rule the world, I only ever have to fool the robot. So I can use any old passport. I can destroy the chip in it, replace it with my own chip. So here's my passport photo, but clearly, I've changed the printed details. So I could do the same for yours.
Your born name wasn't Evil Haxel. So who might want to do that? Obviously, passport fraud's a big problem.
Yeah, so criminal gangs, organised crime, and people smugglers and that kind of stuff.
Can you now delete everything, please?
Yeah. So we've deleted that.
Sure.
I can overwrite it if you want.
I'll take your word for it.
Yeah, I'm one of the good guys, believe me. Hackers and good guys can be the same thing. If you try and infiltrate DEF CON as a Fed and we spot you, in return you get one of these T-shirts. And those are the agencies that have been caught so far.
CIA, Home Security, NSA.
Now we're all friends and we're all on the same side, right?
It's interesting to hear from someone who's been hacking since basically before the internet and who's followed the field ever since to where we are now. As the risks have become better known, it's clear that hackers like Major Malfunction are not only more respected, but they're critical for keeping our networks secure. I just hope he doesn't do anything dodgy with my passport details. Here at the University of Washington in Seattle, a group of researchers is investigating the security of teleoperated surgical robots, machines that a doctor could use to perform a procedure on a patient the other side of the world. In the future, these robots could provide urgent care to people in disaster zones, on the battlefield, or even up in space. But the long distance between the human operator and the robot means that communications between the two could be vulnerable to attack.
We met the team at the Biorobotics Lab to find out how easy it is to hack robots like this and what they're doing to stop it. The Raven 2 is a teleoperated surgical robot controlled by a haptic interface, which means you can direct its movements remotely. Blake Hannaford, one of the robot's designers, told us how the project began.
Well, we started with the military. They wanted a system that could fit inside an armored vehicle in the combat zone. And so that drove us to make it much smaller than other systems that are out there. And as we did that, we realized it was a really good platform for doing research to advance the software, the control, and things like network security for medical robotics. So we just want to get out in front of the hackers.
There are many places where you don't want to send humans. Underwater, a biohazardous area, high temperature firefighting, toxic, radioactive, mining, space. And if you're sending a robot, but you still want the human in control, then you have this communication link, and there's the potential that it can be compromised. So you want to keep that safe and secure.
Tamara Bonacci is an electrical engineer at the Biorobotics Lab. She's been finding ways to hack the Raven in order to figure out what security features we might need to include in teleoperated medical devices.
Can I have a go?
For sure, yeah. Let me tell you how it works and what you will need to do. So please take a seat at our nice surgical chair. And then these 3D glasses. The way you're sending the commands, you will use this haptic interface.
Okay, here we go. I'm going down. I'm going to try and move it across onto this peg here. Ooh, ooh. Yes.
Born natural.
I'm definitely not delicate enough to have this inside someone's body. It's a bit like a claw machine where you're trying to win a cuddly toy, but a lot smaller. And it's strange because when you're looking at the screen here, you almost forget that the actual robot is over there. It's like playing a video game. So I can see how it doesn't really make much difference if the robot is right behind me or if it's the other side of the world, because all I'm concentrating on is this.
It's the distance between the operator and the robot that makes it more vulnerable to attack. As the signals travel across different networks, they could be intercepted. One of the main types of hack Tamara has tried on the Raven is a man-in-the-middle attack, where she disrupts the communication between the user and the robot when they think they're in direct contact.
I'm going to try and control this robot again, and then Tamara is going to hack me and show me how difficult it is to control when I don't have control.
Okay, let's make this harder on you.
Oh. Okay, I can immediately notice that something has happened. And I've already dropped one.
As an attacker, you would listen on the communication over a network. You would try to identify the traffic between a robot and a surgeon. You would try to trick the robot to think that it is talking to the surgeon when it actually isn't. It's actually talking to an attacker, and vice versa, same for the surgeon. For example, you can start blasting some empty messages, packets to the communication network in order to sort of cause the delay.
So there's a delay between what I'm doing with my fingers and what's happening on the screen, which makes it very hard to judge when to close the little pincers.
But in addition to these attacks, there are more sophisticated and severe attacks that can certainly be mounted, where one would exploit the features of the software or of the hardware of the robot. Such a simple thing with such a severe impact on the robot.
It's really frustrating. It's very annoying. The effect is quite subtle, but the impact is very noticeable.
This might be a very sort of sophisticated way of trying to harm the person or even kill the person without anyone ever knowing that that happened.
So you could do kind of a really subtle assassination attempt.
Yeah.
It almost sounds like some kind of sci-fi thriller, this idea of hacking into telerobotic systems that are being controlled in space. How realistic is it that a hacker would actually want to do that?
Well, people have already, as demonstrations, hacked into insulin pumps and pacemakers and automobiles. So how realistic is that?
It wasn't a sophisticated hack, but when you've got a robot doing something as delicate as surgery, even the slightest wrong move could have a devastating effect. The good thing is, this robot isn't operating on people just yet. And unlike what happened with the internet, these researchers are trying to find the vulnerabilities before the bad guys can even look for them. So hopefully, when the robots take over our surgeries, we won't have to worry about assassination by hacker.